Hi, I'm Brian Loos, Project Director at ABB, and we're surrounded by ants right now because these creatures take collaboration to extreme levels. Each ant in the colony performs its own special role so the colony can thrive, which is why they're perfect for discussing how adaptive execution makes it possible to achieve schedule despite complex interdependencies. Today's projects face a lot of challenges. Automation and electrical are highly dependent on other disciplines, and as a result, their designs mature late in the project schedule. The automation and electrical designs also mature piecemeal over the life of the project. Coupled with the fact that projects are increasingly global, with equipment supplied and engineering performed by suppliers around the world, you can see why the ability to collaborate effectively is key in order to succeed. A key technology that enables ABB to collaborate and provides the ability to execute remotely is the virtual engineering cloud environment. We create a virtual version of the automation system hardware and software in a cloud environment which emulates the behavior of the target system. The cloud environment for each project is a single database accessible to all project team members, including the client, the EPCs, the package equipment suppliers, and the ABB team members, including engineering resources in our high-value engineering centers, which is a large and experienced pool of resources available to projects. The cloud environment allows us to sever the traditional dependency between the automation system hardware and the application software configuration, allowing them to progress on separate parallel schedules. We deliver standard hardware cabinets wherever the client needs them at the fabrication yards. We use the cloud environment to configure and test the process control, process safety, and the electrical control application software configuration, including the internal and the factory acceptance testing. Everyone in the project can work from their own location. We no longer bring a large team into a staging location for 6+ months of application software configuration testing. This model saves time and expense of bringing everyone together for extended periods, even more critical in a current environment. Because we've severed the dependency between hardware and software, we can develop the application software configuration later in the project schedule when the design is more mature. Historically, the process and electrical models for operator training were not ready in time for the application software configuration factory acceptance test. Now we can wait until the process and electrical models are ready and use the simulator for factory acceptance tests, which provides value. By incorporating the operator training simulator and the process and electrical models, again in that cloud environment for the factory acceptance test, it provides the ability to perform a virtual commissioning of the system, which pays dividends at site. And projects are realizing the benefits. On a recent large automation project for a chemical complex, ABB received purchase orders from 15 EPCs in 8 countries for an automation system encompassing about 150,000 I/O. All of the development, the internal test, the factory acceptance test of the application software configuration was performed in this virtual cloud environment. The factory acceptance test was conducted using the operator training simulator and these process models. All the team members, the client, the EPCs, and the ABB team worked from their home office location, so no travel was required. Given the global nature of the team, they had to adjust to account for multiple time zones, but it was workable. In another example, a project performing factory acceptance test of the application software configuration using the operator training simulator and the process modeling encountered a problem with an override control arrangement. After investigation, it was determined that the issue was in the process control design, not the application software configuration. Another key enabling technology is the ability to perform remote factory acceptance test of equipment when required. With standard off-the-shelf solutions, smart junction boxes for example, witness factory acceptance test is no longer required. In those instances when witness factory acceptance test is required, we use the technology available to conduct these acceptance tests remotely. The technology for remote factory acceptance tests has been available for a while. However, it really took off when COVID-19 arose. We realized we could work remote and distributed when we were forced to do so. On a recent project, due to travel restrictions, we conducted a remote factory acceptance test for package air conditioners for low voltage E-houses. The EPC was located in Asia, the ABB engineering team was in Asia, and the package air conditioning supplier was in the US. Again, different time zones made for a few late nights for the team members, but it was a short duration and it was workable. A few years back, before the advent of remote factory acceptance test, ABB delivered a project which included 22 telecom systems. The scope included factory acceptance tests at 14 supplier locations around the world, inspections at 21 supplier locations around the world, The FAT and the inspection visits were conducted within a 6-month period, with almost 80% of those visits concentrated in a 2 to 3 month period over that 6 months. The coordination effort to arrange the EPC, ABB, client personnel, supplier personnel, as well as the travel time and the cost to arrange those visits was significant. And if anything moved, it rippled through the entire plant. Remote factory acceptance tests that we perform today could have simplified that process greatly. The virtual engineering cloud environment and technology to support remote factory acceptance test are two key technologies that enable ABB to collaborate effectively on today's large projects.